here in chapter 4, we're finally going to be talking really a lot about the whole business side of things and why the differences mainly between taking this class, the business math class, as opposed to taking college algebra. And so this is really just what chapter 4 is all about. And we're going to start out here at the very beginning of chapter 4 about learning some basic interest formulas. And starting, as you can see here at number 1, is a simple interest formula. And what simple interest does is simple interest helps you find exactly what it says, just simple interest. In a sense of, let's say you let somebody borrow money and it's a good friend of yours and you say, hey, just pay me back after a year or just pay me back after 8 months. And so what simple interest will do is it'll compound. You can either find the number of interest that they're going to pay you. That's what this first formula finds. It just solves for I, which is interest, okay? And that will just determine how much interest that person is going to owe you. Now, if you want to know then how much they're going to actually pay you back, that's where you're going to use the second formula. Because the second formula takes what they borrowed, which is P, that's the principal. Principal always stands for the initial amount, okay? And then obviously PRT right there, that's I. So what this formula does down here is it adds in, it accumulates together, it sums up what they initially borrowed plus the interest that they're going to pay you back, okay? And that's simple interest. It's just you're going to let people borrow money, and after however long y'all decide that they're going to pay you back, okay? And now I want to always reiterate this one point right here, that whenever in the formulas you see P, which P is always your principal, it's always the initial amount that's always borrowed, or the initial loan, just whatever that is. R is your rate, and when you use these formulas, you need to take that rate. It's going to be in percent, so you want to put it into a decimal, okay? And just remember, like if you have 8%, what that equals is 0.08. You just move that decimal that was there, and you move it 2 spots to the left, okay? So if it was 7.5%, then what that equals is 0.075, okay? And the last most important thing out of anything in terms of learning what the variables mean is that when you see T, it always stands for time in years. It has to be in years. So if they give you that you're going to borrow money for 8 months, you don't put 8 in for T because that's going to assume it's 8 years. What you need to do is you need to convert that to years, which is 8 over 12 years. So just if it's in months, just divide it by 12. And if you want to reduce that fraction, fine, but just know that whatever T is, it has to be in terms of years. That's what the unit is. Okay. All right. So simple interest is just borrowing money and not paying it back, applying interest at the very, very end, and then paying that back. Okay. What compound interest? This is more realistic because what compound interest does is, let's say you're going to borrow money from the bank, or you're even going to let the bank borrow money from you in the sense of you have a savings account or a money market account. And what compound interest does is instead of them just applying interest one time throughout the whole entire loan, they're going to apply interest periodically throughout the loan. And so they could either apply interest just annually, which is 1 time a year, so y'all write 1 right there. Semi-annually, which is twice a year. Quarterly, obviously, is 4 times a year. Monthly is 12 times a year, and daily we're going to go with 365. Some books actually say 360, but I wonder if does they incorporate holidays? I have no idea, but we're going to go with 365 for daily, okay? And so what this means, and just think about it here, you're going to have a principal amount of money. Here's P right here. You're going to have a principal amount. Let's pretend like we have a savings account, okay? So you have a principal amount of money, and let's say we're going to compound quarterly. What that means is for 4 times every year, the bank is going to take your principal, your outstanding balance, throw it through this formula, add on interest. And then that new sum is going to just sit there in the bank account until the next quarter comes around. Then it's going to take that money, that new balance, throw it through this formula, add some interest in, and then let it just sit there for the next quarter. And then one more time. And then let's say that's going to happen for 5 years. So for 4 times a year, 5 years, so a total of 20 times, your money has interest being added to it. Okay? Some other things to know, obviously, in here is this little m. And m for this formula just represents, obviously, what you can tell is how many times it's going to compound in 1 year. Okay? So what this exponent represents, by the time you do the number of compounds each year times t, the total number of years, that'll be the total compounds in the loan over the whole entire life of the loan, if you want to consider that, over life of loan. Okay, and that's what that whole exponent is. If I can give you guys any hint, when we start using that formula and you start pulling it and using your calculator, this is the biggest hint I can get you, because it's a lot of times people will put this wrong in their calculator, but if you go in there and put your base, just make sure you do that m times t in parentheses. So when you want to throw in that exponent up there and you do caret and then do your exponent, make sure you open up a brand new set of parentheses and you put m times t in parentheses. That's the biggest hint I can give you. So this is going to be some easier stuff, and then the only time you would ever mess it up is just not typing it in correctly in your calculator. Okay. And if you can look through here, just read through the terms on what A represents, what P represents. It's always going to be the same every time. Okay. All right. Now, if m represents the number of times it can be compounded, so annually is 1, semi is 2, monthly is 12. What if I want to consider like my money being compounded? Because you think, oh, the more time it gets compounded, maybe the more money I'm making. Well, in general, they tend to give you a lower interest rate if they're going to give you a high compound, by the way. So if they're going to be compounding your money daily, guess what? Your interest rate for daily is probably going to be a little bit lower than your interest rate for annually. Because, banks are smart that way. But we have this other formula right here called the continuously compound interest. And what this is if you are going to try to describe something that's even happens every minute, every second of every day, in the sense of your money is constantly money's constantly being added to your balance, okay? And this is the compound interest formula. And if you look at the formula, there's a typical A, that's the amount that's going to come out at the very, very end. P is the amount you're investing. R and T are your rate, so make sure you put those in parentheses. It's your rate times the total life of the loan. And notice how it's missing the M, because we can't really describe M in terms of a number. It's like, how do you represent every minute of every second of every day? You can't exactly say, oh, that's M equals 1,000 or something. You can't say that. So what they do is they've developed this formula. And that E right there is the same E that's attached to your LN button on your calculator. That's the E that we talked about in the last chapter with logarithmic function, the natural log function. Okay, it's the exact same thing. So when you type this in, let's say you had $10,000 and you had E to let's say the rate was 8% for a total of 10 years, then what you would do in your calculators, you would type 10,000, then second LN. It would open up a caret already with the parentheses, type 0.08 times 10, close parentheses, and that's it. Okay? All right, let's go down to this next formula. Let me describe to you what effective rate is. Effective rate is the best way anytime you're wanting to compare two interest rates. Okay? So what this does is it compares the simple interest rate, which was our very first formula, with our compound interest rate, which was our second formula. And what this does, it takes a rate that, like for the compound interest one, it takes a rate, let's say your money was compounded at 7% quarterly, and what it does is takes that rate, the 7% quarterly, and says, well, what if instead of quarterly I only want to do it one time a year? Then what should be my interest rate if I only want to apply interest one time a year? And this is what this formula does, is it compares two rates. It basically, or if you had, let's say on your compound interest, you were going to compound it monthly, so 12 times a year, and then what this formula will tell you, well then what does that interest rate need to be just to do it one time a year, okay? So it's a way to get the exact same money coming out after 1 year, but at two different rates, okay? So it's just the easiest way to compare rates. If you ever have a problem and it says, hey, what's better, to earn this much money at this rate or this much money at this rate, then this is the formula you're going to want to use, okay? And sometimes you've heard of this word APY, or annual percentage yield, especially when they're talking about credit cards. That's what they're talking here, okay? And as you kind of look at this formula, look how it says, I put REFF, the subscriptor stands for effective. So the effective rate is equal to, and look at everything here on the right. It doesn't have A, has nothing to do with the amount of money coming out, doesn't have anything to do with the amount that's invested. It's just a way to compare two rates. This rate over here on the right obviously is being compounded because you have M's. So it's a way to compare a compounded rate to a basic, just simple interest rate. Okay, let's go on to example 1. Here in example 1, we want to find the simple interest on a $1,000 investment made for 3 years at an interest rate of 5% per year. What is the accumulated amount? Okay, let's just do 2 things. Obviously, if it says simple interest, you're going to use the simple interest formula. If it doesn't say simple interest, you're not going to use it. Okay, it's as simple as that. You see those words, plan on using that formula. Okay, well we'll write down our information. You have a $1,000 investment, so that's your principal. That's what you're initially putting in, is $1,000. We're going to make it for T for 3 years. It's already in terms of years, so T is 3. The interest rate is 5%, so let's go ahead and write that as 0.05. Okay, so if I just wanted to calculate the interest earned totally, sorry, I shouldn't write that as an I. The interest rate should stand for R. Be helpful if we had that right. Okay, so if you just want to find the interest earned, I is equal to PRT. Okay, so if we do 1,000 times 0.05 times 3, and all we have to do is plug that in our calculators. So the interest comes out to be $150. Okay, so that's just the interest earned. Now, the second part says, though, what's the accumulated amount? So if you put a $1,000 investment, after 3 years, then how much is coming out? Well, that's what that second part says in that first formula we have up there. The accumulated amount is the amount you initially invested plus the interest. So the accumulated amount was that $1,000 plus your interest, so it's going to be $1,150. And that's it. Okay, let's go on to number 2. We wanted to find the accumulated amount on the $1,160 after 2 years, and the simple interest, there's the words again, rate is 8% per year. What is the principal? Okay, the accumulated amount, so A this time is 1,160, 2 years, so T equals 2. We have a rate of 0.08, and P is what we're looking to find. So A is equal to P times 1 plus R over T. And remember, I know to use this formula because it doesn't say anything up there about compounds. So I definitely don't want the compound formula. I want the simple interest one right here. We know that the accumulated amount is 1,160. P I want to solve for. And then the rate is 0.08 times 2. Okay, so let's get that in our calculators. We'll get 1,160 is equal to P times 1.16. And then obviously just divide both sides by 1.16. And we'll get an initial investment of exactly $1,000. All right. Let's go on to part 3.